Welcome back. We are still implementing the Code Week edition of Flagship Game. Now we are here to see how to randomize the placement of the flags into the grid. So in the last session, what we did was to develop an interface which looks more or less like the mockup that we had, in the sense that our flags are properly placed in a grid, which is a 4x4 grid. So 16 flags are taken from the list of all the flags available, and in this edition we have 38 flags corresponding to the 38 countries taking part in Code Week, and the 16 of them are extracted from the set and placed in the grid. We did something which is smart enough here to place flags in order to do it by coding rather than by hands, and this is a big advantage for two main reasons. The first one is that instead of repeating boring operations 16 times, we had just to write code that tells what to do with each flag and how to place it in the grid, and this code is repeatedly executed by slightly changing some parameters in order to make both the position and the flag different from place to place. So this means that we specified the settings for each flag here in a parameterized way. And the parameters are x and y, which are the positions, and row and col, which represent the row and column in the grid, and k, which represents the order of the flag that we want to place. However, what we did in the previous session was static in nature, in the sense that even if the flags were placed and extracted from the set by code, meaning that we didn't place them statically in the interface, but we wrote the code needed to place them, the result of the implementation and execution was always the same. This means that every time we started the game, we found exactly the same flags and shown in the same order, and in particular the flags are associated with the names of the countries, which are represented by their acronyms here, so that using this list in the piece of code that we wrote, it always takes the first 16 flags in the list. So the flags are always the same and placed always in alphabetical order. This means that there is no challenge in the game. So right now we have to add randomization. Actually, the code that I'm showing you is already implemented, just because I conducted a live coding session, but unfortunately recording didn't work. So I have now to explain what I did instead of explaining it while doing it. I'm sorry if it is less effective, but I cannot, there is no time during Code Week to redo it from scratch, so I prefer just to comment what I did before. So first of all, notice that we have a restart button in our mockup. So we want the restart to rebuild the interface exactly as we launched a new game. So instead of placing the initialization functionalities, which are this one, directly within the when initialize block, I prefer to define a new procedure called new game that can be called both at initialize and when the restart button is clicked. So in this way, I can write this routine just once and use it twice, instead of repeating the code in both cases. Okay? So let's see what's inside here. Inside here we have what we already had before, which is prepare screen, which was done 2 sessions ago, and place flags, which was implemented in the last session. Now we have to deal with get data. Get data contains calls to 2 different routines. The first one is randomize, which has the effect of providing a random list of numbers which represent the positions taken by the countries in the original list that have to be represented in the grid. So this means that we start with a list of 38 countries, and then we invoke this function here that returns a list of 16 numbers. Each number is a number from 1 to 38, which represents a position in this list, which is the position of a flag to be taken and represented in the grid. Then this second routine, which is extract subset, does exactly what I mentioned. So given the original list of countries and the list of positions in the list of the countries that we want to represent, it takes them out and builds a subset that is used in place of the original set of flags. Now, if we take this subset instead of the original set, which was called countries, into this routine, which is the place flags, the result will be different every time we launch the application and every time we click on restart. So in the previous code, I made just a very small change, which is this one. Here, I use the list, which is called the selected countries, in place of the total list of countries. Using the total list of countries will always return the same result, which are the first 16 flags placed always in order, while if I use the selected countries list, the 16 elements of this list are randomly sorted from the entire set. So they will look different at every launch of the application. And if you remember from our discussion on the specification, there are as many possible combinations of these flags as stars in the universe, as atoms in a mole, and so on. So there are many, many, many different combinations that it is completely unlikely that you find twice exactly the same instance of a game. Okay, let's look inside the 2 routines that we implemented. The first one is randomize. Randomize does this. It initializes a set which is just a set of 38 integer numbers from 1 to 38. Actually, it goes from 1 to 38, but it is parameterized. You see, there is an input here. I would like also to mention that the procedure that I'm using here is slightly different from the ones that I used before, like this one or this one, because as you can see, it looks a little bit different, because there is a return value. In fact, notice that the call to this routine, which is randomized, is different as well, because when we called get data or prepare screen or place flags, we did it directly, while here we do it into an assignment statement. So we are setting a new variable to the result of the execution of this routine. So we need to have a result back, and this is why we have this kind of puzzle. Now we define a local variable which is called set and which is initialized as an empty list, and then a random subset, which is another list initialized to empty. In the inner loop, we have in the inner code, we have 2 loops. The first one, which is used to initialize the original set, and as you can see, there is a parameter k which goes from 1 to n, which in this case is 38, and for each value of k, an element k is added to the set. So at the end of the execution of this piece of code, set contains 38 integer numbers, so from 1 to 38. Then here we repeat this loop 16 times from 0 to 16, and at each iteration we select a random number from 1 to n at the beginning when k is 0. This is chosen from 1 to n. Then this is an element that will be added to the list of selected elements, which is the random subset, and it will be removed from the original set. So that at next iteration, there is no chance for this element to be selected again, and the number that is randomly generated has to be taken from 1 to n minus 1, then from 1 to n minus 2, and so on. At the very end, k will take value 15, and the final element will be taken from 1 to n minus 15, because 15 elements have already been selected and taken away from the original set. What happens here when we add an item to the list? The item that we have to add to the list, which is the return value, which is the result of the execution of this routine, is not directly k, but it's not directly the random number generated here, but the random number is just used to select an element from the original set. So, as you can see, we use the random number called element to select one of the elements of the set, and this element is moved to the random subset, and then the random subset is returned. Now, once we have the randomized array here, this is an array containing the 16 positions of the flags to be taken from the original list of countries. So here we have the extract subset, which takes in input the original list of countries and the randomized positions. And as you can see, it does this. So it takes these two values, which are called here array and elements. You see, array and elements. Array contains the list of countries, and elements contain the positions of the elements that we want to extract. So for each element, we add, so we are using a local variable called subset. And in subset, we are adding the elements taken from the original list found at the position specified in the elements array. So for each value of the elements array, an item is added to the subset, and this item is taken from the original array at the position specified in position k of the elements array. Okay? I hope this is clear enough. I understand that it is not straightforward, but let me show you how it works. So let me save the APK on my computer. So I'm waiting for App Inventor to build it and to save it on my computer in order to be able to show you how it works on the emulator. Okay, almost done. I think that App Inventor server is a little bit overloaded today because of Code Week, so it is much slower than usual. Okay, 100%. Let's wait for it to download. Okay, here it is. So let me take it. Okay, this is our first page. Play the game. And here is the effect. Now the flags are not the first ones in the list. And if I go back and play the game again, they are different and in different position. And if I press restart, a new configuration is provided. Okay, that's it for this session. Thank you very much. Bye-bye.